Hello, we're going to look at arithmetic and geometric sequences. Some of the things on this page will actually apply in the next couple of topics as well. But let's look first at the difference between arithmetic and geometric sequences. There's a common difference, meaning you add or subtract each time a same distance between each of these, such as you can see here we plus 2, plus 2, plus 2, so it's adding 2 every time. If it was reversed, 11, 9, 7, 5, we'd be adding a negative 2 each time, which we call subtracting 2. So there's a common difference of positive 2. Call that d equals 2. In a geometric sequence, it's a ratio, and the number is going up by a multiplier, so it gets larger much faster than it does in an arithmetic sequence. So here in this case, this one looks like it would be multiplying by 2. Multiplying by 2, multiplying by 2. If it was the other way around, we would not be saying dividing by 2, because this has to be multiplying, not dividing when you go from one to the next. What's confusing here can be that by the way, we call this, when we say this is called a ratio. This one's a common difference, this one's a common ratio, so the ratio is 2. Now, if the numbers are decimals or something about them seems unusual, the strategy to figure out exactly what the ratio is take one of the numbers and divide it by the one in front of it. Happens to be 2. Then you do that with the next pair. You take the third number, in this case we'll do second and first, third and second, and then fourth and third. So we take that one and divide by it, we get 2. And we go to the next pair and take the second one and then divide it by the first one, or in this case fourth and third. If it is true for every single one of them, then this is indeed a geometric sequence. This proves it because we got the same ratio each time. It has to be the same each time. So this gives us a ratio of 2. This one gives us a common ratio of 2 and a common difference of 2 in this case, but definitely different numbers. Now, one of the skills to have here is to make an equation for the arithmetic sequence 5, 7, 9, 11. Same one that's here, so we figured out that this is d. All right? So there are two methods to find the equation. One of them is to use this formula here, and we're going to start with that, and then we're going to look at another way to do it. If you memorize this formula, then you can put the things in it. So let's talk about what each of them is. An is the amount of the nth term. Now, what I mean by that, when we look over here, let's look at this one. This one is the first term, so I'm going to do A1. This is the amount of that first term. This one's the amount of the second term. This one's the amount of the third term, and this one's the amount of the fourth term. So that means, and I guess I should have written that over here with these, but same idea. So I have 5, 7, 9, and 11. So we want to know the amount of the nth term. We don't necessarily know that amount. But in this case, we do know the amount of the first term. Amount of first term. And then here the n is the number of the term. And that's the number of the term we're trying to figure out that amount. So if we wanted to know the amount of the fourth term, we already know that the fourth term is 11, so this would be an 11, and this would be a 4. And then it's minus 1, and then this, of course, is that d, the difference, the common difference. I'll put com diff. So that's the common difference. So in this case, to make the equation, we make the equation where we don't know yet what the amount is. I used 11 and 4 before as an example how they pair up. The fourth one would be 11, so it would be a 4 and that would be 11. But we don't know. Maybe we want to know the 30th, so it would be a to the 30th and a 30 here. We don't know that. So these two depend upon what you're looking for, but these two you can figure out because we know the first term and we know the common difference. So what we would do is do an equals 5 plus n minus 1 times 2, the common difference. This is not acceptable. Must work it out. Very important part. This would be an incorrect answer. You have to multiply it until everything is as simplified as possible. So what I would do first here is multiply the 2 to both of those, and equals 5 plus 2n minus 2. And then I see there are 2 numbers here, so I can combine those. And I want you to get in the habit of putting the one with the term with the n in it in front. It's not essential. It could be said as 3 plus 2n, and that would be okay, but it's not a good habit to get into. Okay, so that's a. I should have a little. It should be a little n down here. So I'm going to rewrite it just to show that it's that subset. No, yeah, I think it's just sub for it. 2n plus 3. Now, there's another way to think about this. Here's 5, 7, 9, and 11. I'm going to write this slightly differently. 5, 7, 9, and 11. And I'm going to say that's the first term, second term, third term, and fourth term. I can say A1, A2, A3, A4, but if I put 1, 2, 3, 4, and I make boxes here, I can get the same result, but I can do it by solving it as if it was a slope-intercept form equation. Arithmetic sequences are actually straight lines on a graph because there's the same difference between each of them. So I'm going to call this x and call this y. So I actually have pairs of numbers here. I have 1, 5, x and y, a 2, 7, a 3, 9, a 4, 11. Oh, now that's an interesting combination of things. What this does is tell me that if it's a straight line, I can write it in the form of a slope-intercept equation. Y equals, oops, I've got to remember mx in there. So I can make a slope-intercept form equation. That means my first thing is to find the slope. So if it is the same exact d between each of these, plus 2, plus 2, plus 2, that happens to be the slope. Let's prove it by doing the slope formula here. I'll take these first 2 numbers, y minus y over x minus x. That's 2 over 1. I could do the same thing with these. 9 minus 7 is 2 over 1. 2 over 1. Any combination here of them. And so I get a slope of 2. So I have 2x minus b. All I need now is b. Oops, I meant to, let's say, I figured out m there, so let's make this y equals 2x. Y equals mx plus b. Don't know the y, don't know the x, because this is set for any y or x or any pair. But now I know the slope, now I need to find the y-intercept. If this had been a 0, that would be the y-intercept. So one way you can think about this is I could go backwards, since I know it's plus 2 every time. If I wanted to go a 0th term, or when it was a 0 here, I was going plus 2 every time. I can go minus 2 and do a 3. So that means that this should be a 3. Let's prove it by taking any one of these pairs of numbers and putting them in here and solving for the b. I'll take the third one this time, 3 and 9. The y is 9. 2 times 3 minus b. That's 9 equals 6 minus b, and when I subtract 6 on both sides, that confirms that the b is indeed 3. So I would say y equals 2x minus 3. Oh, wait a minute, I don't know why I kept doing minus. Something weird here, and that's why. The slope-intercept form is plus b. Y equals mx plus b. Y equals mx plus b, plus b, plus b. So this is a positive b, as it should be. That means this is a positive 3. Okay. Good thing I always go back and check my negatives. Most of the time I catch an error, or when I do catch an error, it really feels good that I fixed it. That's what I did here. Look at these. I'm going to write them both here since there's more space here. An equals 2n plus 3. Y equals 2x plus 3. Same thing. So what this shows is that these are functions, because when you input the number of the term, you get back the amount of that term. And that amount depends upon what number of term it is. This is a dependent variable, a dependent thing you're looking for. And in that same way, when you say y equals 2x plus 3, the y is the result of whatever the x is. You just have to do the stuff here to the x. Both of these are acceptable ways to write it. You can memorize that, and you should know it anyway, but you memorize it, you fill it in, you must work it out. I want you to get in the habit of putting that in front, because when you do it this way and you do slope-intercept form equation, you absolutely must always put it in this form anyway. So this one's like you've done many times, of course, where you find the slope. If you have a linear graph or such, you can take the points and make a slope and solve for the y-intercept, and voila. So those are the basics for looking at sequences as functions.